Hello and welcome to another one of D's ADD videos. Today we're going to look at the concept of orbitals and electrons that travel through these orbitals. Before we talk about electrons and their orbitals, let's talk about electrons as waves. So if we were to look at electrons as waves, there's different things they can do. They can diffract, and diffraction basically means the waves can either constructively or destructively interfere with each other. Okay, so if they cancel each other out, they destructively interfere. If they boost each other up, then they constructively interfere. There's two types of waves. There's traveling waves, in which the peaks and the troughs travel horizontally, or there's standing waves, in which the peaks and troughs don't move horizontally at all. That's kind of like if you were to think of a guitar string being plucked, would be a standing wave. Nodes have points in which their amplitude is zero. Okay, and the wave function psi is the wave that corresponds to the electron. Orbitals are the places where the electrons travel, and the wave functions for the electrons and atoms are assigned to the orbitals. So there are some numbers that it can be used to describe the different elements. An element itself has four unique quantum numbers. The first of the quantum number is the principal quantum number, and that refers to the different shells of the periodic table, or the different periods. Okay, so that's principal quantum number 1. Here's number 2. Oops, the second row, third shell. And these are corresponding to concentric spheres. That's one sphere inside another shell that the electrons can travel in. Okay, so N. Good metaphor is the onion metaphor. There's one layer, then there's a space, and then another layer, and then a space. Okay. The second quantum number is going to give us the actual subshells. Okay, and that's L, and its maximum value is n minus 1. So if n is 3, for instance, L can be 0, 1, or 2. And we'll go through all that in detail when we start looking at the example videos of quantum numbers. Okay. M sub L gives us the actual subshells into individual orbitals. And these basically have to do with the orientations in space. Okay. So for instance, the p orbitals, there's 3 of them. If we were to look at the p orbitals, let's see if we can find some orbitals here. No orbitals there. Maybe over here. No, there we are. So I already gave you the s orbitals. The s orbitals are the spheres. This would be one sphere, and then outside that there could be another sphere, and then outside, depending on what your n is. Then the p orbitals, you can see that there's 3 p orbitals. Let's look at the p orbitals and zoom in on those guys. So there's one aligned in the z direction, one aligned in the y direction, one aligned in the x direction, and if you put them all together, you get how the p orbitals look. It took me a while to draw those. But basically, you can have 2 electrons in each one of these orbitals, so the p orbitals can have a maximum of 6 electrons. Okay. So basically, you can take each one of these times 2, and you can figure out how many electrons they have. M sub s is the magnetic spin, and the magnetic spin basically states that it can either deflect the cathode ray of electrons up with a positive 1/2 or down with a negative 1/2. Okay? And what you'll need to be able to do is you'll need to be able to write the 4 principal quantum numbers for any element, ion, or be able to go from 4 quantum numbers and determine what element it is. Okay? So in order to do that, you're going to need to know a few rules. Okay? So the first rule is the Pauli exclusion principle that says that no 2 electrons The same atom can have identical values for all 4 quantum numbers. Okay, that's what allows us to identify one element versus the other given the 4 quantum numbers. So this also leads to the fact that there can be only a maximum of 2 electrons in the same orbit, and they have to be paired in opposite spins. Aufbau principle talks about when we're filling up, we have to add orbitals with the lowest energy first, like S, then you work up to P and D and all the other ones. Whereas Hund's rule tells us we have to first, let's say we're looking at the p orbitals. Before we can start pairing up the p orbitals, we have to put one in the x, the y, and the z prior to pairing them up. That's what Hund's rule says. Okay, so they have to be spread out as much as possible. All right. The valence shell is the outermost shell of electrons, and that's where the chemicals reactions occur. And it's the largest value of N that we have. Valence electrons are the electrons in the valence shell that determine the reactivity of whatever we're looking at. And then there's the shorthand configuration, in which when we're doing electron configuration, we'll talk about that. But basically what happens there is we look at the filling up of each electron orbital using Hund's rule and Aufbau principle, and we're able to come up with an electron configuration. All right? All right, that's basically it for this video. Make sure you check out the example videos in which we go through all this in detail. The orbitals themselves, you can see, can get pretty interesting. Spherical, then the dumbbell, and then look at the d orbitals. Okay, that was a little too fancy. Look at, we're here in the xy plane. Okay, here this is the yz plane, and you can see we have some really strange shapes. Or if we go down here to the f orbitals, look at that, it gets pretty crazy. Let's zoom in on that one. Okay, so here we have 7 orbitals. 1, 2, 3, 4, 5, 6, 7. Each of them can house 2 electrons, so that's why we have the 14 right there. So make sure you check out the example videos that have to do with these orbitals. This is a point of confusion for a lot of people. So go ahead and try to get it straight. You'll see it again in organic chemistry if you take that. And also check out the videos that have to do with the calculations of waves. You should be able to find wavelengths given frequencies or given velocities and Planck's constant, whatever else is given. All right? Find the energy. And I also need to find some energy, so it's time for me to rest. I hope I've cleared up any doubts that you might have. Practice, practice, practice. Thank you, and have a nice day.